Alright, so up next we have question 6, which proved to be quite a difficult question, with only around 23% of students getting the correct answer. So what we've got is a matrix transformation, which maps us from R2 to R2, which is defined by T of xy equals the following matrix times xy, plus on the following vector, -1, 4. So hopefully most of you have seen questions like this, but they're sort of not covered exceptionally well sometimes during classes. So it can be quite a tricky question. So we're asked to look at the image of this curve under the transformation, and it says that we can write it in this form here. So y equals ax squared plus bx plus c, and we want to find the values of a, b, and c. So the first thing we need to do is we sort of need to expand out this matrix business here. So what I'm going to do is I'm going to call this an x prime equals, and all I'm doing is I'm looking across the top line of my matrix. So I'm going to have 3 times x, 0 times y, so I'm going to have 3x there, and then I'm going to subtract 1 from that. So that's sort of my top line of my matrix transformation. So just to go through that again, the matrix multiplication goes such that the 3 is multiplied by the x, so this 3 by that x, that 0 by that y, which gives me 3x plus 0y, and then I collect up this -1 to give this equation here. Alright, so the next one is going to give me 0x plus 2y, and that's going to be the y dashed, so I've got that y dash from down the bottom. I've got my x dash from up the top in the previous equation. So the y dashed is equal to 2y plus 4. Alright, so I've done the same thing here. I've got 0 times x, 2 times y, plus 4. And that gives the second equation that we're looking at. So now these are sort of our transformed points of the graph. So my next sort of process is to solve for the normal x. So I want to isolate out this guy here and isolate the y there. So I've got to sort of undo what's happened to these inside each individual equation. So this one here becomes x dashed or x prime plus 1 divided by 3 equals my normal x. And this y here becomes y prime minus 4 divided by 2 equals my normal y. So now at this point, we sort of do an old becomes new. And what that means is that we're going to sub in this and this into our original y equals 2x squared plus 1. So what this becomes is y is now y dashed minus 4 divided by 2 equals 2 times x, but x is now x prime plus 1 divided 3 squared plus 1. Alright, so now what we've got to do is we've just got to get it into the required form, which was specified up here. So to do that, we're just going to multiply through with the 2. So we're going to have y prime minus 4 equals 4, x prime plus 1 on 3 squared plus 2. And then I'm going to add on the 4. So if I just get myself a little bit of extra room over to the side. So I'll start up the top. I'm going to have y prime equals 4 times x prime plus 1 on 3 squared plus 2 plus 4, which equals plus 6. So hopefully I've got all that right. Then what we're going to do is we're just going to expand out the bracket in here to get it into the form that we wanted. So we're going to have y prime equals 4. I'm going to take the 3 squared on the bottom line out the front. And we know that x plus 1 squared is going to give x squared plus 2x plus 1 plus 6. So again, just going to expand this bracket by multiplying each term through by the front coefficient. So we're going to have y equals 4x squared on 9 plus 8x on 9 plus 4 on 9 plus 6, which I can rewrite as 54 on 9. Alright, so hopefully 54 divided by 9 gives me 6 in return. I think that looks okay. So I can rewrite this as being a equals 4 divided by 9, b equals 8 divided by 9, and c will equal 4 plus 54 is 58 divided by 9. And that there is the final answer to this question.